Good day, everyone. Welcome to the third in a series of Stormwater Pond webinars presented by the National Municipal Stormwater Alliance. My name's Randy Neprash. I am talking from the Twin Cities in the fair state of Minnesota. And we're gonna move into our webinar. Next slide, please. Here's what we're going to be covering today. We're going to do a brief introduction, talk about NMSA a bit, also talk about a draft stormwater pond decision framework that we would ask you folks to take a look at and give us some feedback on. We have a series of speakers covering various new technologies related to stormwater ponds. We'll have a Q&A at the end of all their presentations, and then a wrap up at the end. Next slide, please. Our speakers today, there's me. I'm with Stantec, the Minnesota Cities Stormwater Coalition, and I'm the vice chair of NMSA. We also have Seth Brown, Dr. Seth Brown, who's the executive director of NMSA, Pete Littleton from Corvias Solutions, Bob Hawley from Sustainable Streams, Matt Wooten from Northern Kentucky Sanitation District No. 1, and Scott Struck and Chris Wessel from Geosyntec. Next slide, please. This is the third in our series of 4 pond webcasts. We want to thank the Chesapeake Bay Trust, which provided the funding to support all this. Our first webcast talked about problems that have been found fairly recently in constructed stormwater ponds. Second one was looking at ponds as assets and applying asset management principles and technologies to them. Third is where we are today, talking about new technologies that can be applied to existing ponds. And then finally, our last webcast will cover the municipal perspective, the direct experience of some local programs in managing their ponds. Next slide, please. Some housekeeping, please. And we want to be careful with this. So you should know that the webcast is being recorded and it will be made available, and we will distribute that information. You can also request it by sending an email to Seth to get the link to the webcast recording. There are PDHs that are available for folks that are listening and attending today. And again, send a request to Seth. We're going to, everyone who's not speaking is muted. We're going to ask you to use the control panel and the question function to type in questions that we will curate as we go along and then use as the basis for the Q&A at the end of the webinar. If you have any technical or technological questions, how's this system work and why isn't it working for you at the moment, please use the chat function and we'll try to get things resolved for you. As you go along, we're going to ask a few simple, quick poll questions, ask you to respond quickly, but those have proved to be interesting and useful in our earlier webinars. And finally, you have a document waiting for you in the handouts section of the control panel for this webinar. It provides details about this decision framework that we are suggesting. So we ask that you take a look at that. You can download it. If you click on it in the handout section, it'll open up in your web browser, and then you can save it from there. Next one, please, Seth. So here's where we are today. We're going to talk real quickly about the big picture related to stormwater ponds, a bit of background about NMSA, and then a bit more information about this stormwater pond decision framework that we've put together in draft form. Next, please. So we thought we knew and understood constructed stormwater ponds pretty well. It's one of the oldest, simplest types of best management practices or stormwater control measures that we put in place. We have thousands of them, especially in, say, the central and eastern part of the United States. We've counted them in Minnesota. We've got just the MS4 cities have more than 14,000. Their best estimate for the Chesapeake Bay is in the neighborhood of 60,000 constructed stormwater ponds. Our understanding of how they function is still true, but now we have some new information that's come forth in the last several years, which essentially runs into the category of good news and bad news. So next slide, please. We've found some unexpected problems in our existing stormwater ponds, and we'll suggest, if you're interested in those, to take a look at webinar number 1. We also have exciting opportunities to enhance the performance of existing ponds, and we're going to talk about those in the webinar today. Remember the comment about how many of these ponds we have? If even a small percentage of those ponds have significant problems, that's a big deal for our local systems. And also, if these retrofits that can be done very cost efficiently can improve the performance of a percentage of those ponds, that's also an important piece of news. And finally, we recognize that all these ponds merit and need proper management and maintenance. Applying public asset management systems to these ponds is probably almost certainly worth the effort. And that's what we discussed in webinar number 2. Next slide, please. In the webinar series, we want to present new ideas to you and test them. We're interested in your opinions, your questions, and your feedback, both today and after this webinar. We want to explore building a national consensus to move ahead with options, and we want to explore a decision-making framework that can help local implementers consider their options and make sound decisions. Next slide, please. So who's NMSA? We're the organization putting this on, National Municipal Stormwater Alliance. We are a coalition of MS4 permittees. We're the only organization in the country that is comprised almost entirely of MS4 permittees and focus solely on issues and concerns related to MS4 permits and their local operations. Our members are organizations, not individuals. They're state and regional level coalitions of MS4 permittees, and we also have some affiliate members as well. Our state and regional member organizations, each one of them represents at least 5, in most cases a lot more MS4 permittees in each state and region, and our affiliate members are consultants, technologists, law firms, manufacturers, or other companies or organizations that are focused on the MS4 sector. Next slide, please. So this map gives you an idea as to the organizations, the states where we have member organizations, all these blue states. We've added a couple since this map was done. We're up to 22 state groups currently members of NMSA, and then we also have our affiliate members as well. The plus signs indicate locations and states where we're currently in conversation with groups of MS4 permittees. Next slide, please. And here's our leadership. The NMSA chair is Scott Taylor, based in California. I'm the vice chair in Minnesota. Jennifer Watson is our treasurer, based in Tennessee. And Dr. Brown is our executive director, based in the Washington, D.C. area. Next slide, please. And with that, I'm going to hand it over to Seth Brown. Seth, take it away.
Thanks, Randy. So I'm going to take a few minutes to talk about something that we put together that we refer to as a Stormwater Pond Decision Framework. And this is something that it's associated with the grant that we have. What we wanted to do is produce a product that municipalities can look at as a way to start considering how they would address ponds within their community. So this is a draft version. Randy mentioned that if you go to the handouts area, you can download more information on this. I'm going to spend about 2 minutes talking about this. You can spend more time, and we would invite you to. But I just want to provide the context again. This is something that it's a starting point more than anything else for communities who are thinking about where do we start. We've got hundreds of ponds, maybe thousands of ponds. Where do we start? How do we move forward with addressing the issues related to that? Understanding what are the dynamics, what are the opportunities out there. So this is an initial draft version. We're looking for input from everybody who's got some thoughts on it. What we've put together is based upon the EPA fundamentals of asset management framework. We've also took some of this from a framework put together by Trey Shanks, who has laid this out in the North Texas area and other places in the South and Southwest, or Southeast, I apologize. And I'm not going to go through all the steps, but you can see those steps that are laid out there. We've got 7 steps. You could have 6, you could have 10. We chose 7 on this. We'd love to get input from others as much as we can. We do know that there are other decision frameworks out there. There's a million ways to look at this. You could have flowcharts. This is an example of a flowchart that kind of gets to the same type of thing. This is from Kitsap County in Washington, the state of Washington. They're looking at, they manage half of the ponds in their area. And this is a way for them to understand how can they make decisions about retrofitting as an example. This is another example from EPA Region 1. I think it's from New Hampshire. Again, it's an 8-step process looking at retrofitting in general. We're talking about specifically focused on ponds. So I'm not going to go through all these questions, but all this information is made available for you to look at. If you're really interested in providing input, we'd love to see it. But these are the kind of questions that we're hoping to get addressed through this input from different folks. So what to do now? Again, the PDF that's in the handouts area in your GoToWebinar app there, you can download that. If that doesn't work or you don't get that now, then you can ask us for it. You can email me at seth.brown@nationalstormwateralliance.org. I'll get that to you. If you can provide input, usually following those questions that we provided, please email and put in the comment or in the subject header comments on Pond Decision Frameworks. That way I can more easily organize all of this stuff. We'll take all this input and we'll make a final framework, and we'll make that freely available to the sector. That's just something that we're doing through this grant. And if there's any questions on it, again, you can email me on anything else. So here's our speakers. I want to get on with things. We're going to start with Pete Littleton. He's going to talk about ponds on the P3 perspective. But before we do that, I want to launch a very quick poll just to see who is on who's joining us today. So if you can take a quick second, we'll just have this open for just a little bit. You guys have seen these kind of polls before. It's really good to understand where who's engaged here and who's in the audience, so we know who we're talking to. We've been trying to target as much on the public sector side, nothing against consultants, but we really want to make sure that we get direct information to stormwater program managers themselves. Of course, a lot of consultants also provide support, obviously, to that sector. So it's just good to know who's in the audience. Okay, looks like we've got most people have voted. So I am going to close this and share this. So you can see we have most folks are stormwater program managers, which is great. We're reaching the audience that we want to reach, and that's great. So we're going to have a couple more polls like this as we go along. So be aware of that. I'm going to hand this over now to Pete. Before we do that, I just want to again highlight the fact that we're looking for questions. So use the question function anytime. I'll be going through those, and then we'll have a question or two quickly for each presenter, and then at the end we'll have time for a larger Q&A discussion. So if your question doesn't get addressed initially, don't fret. We will have more of an opportunity in the future. So Pete, if you're ready, I'll share my screen. You tell me when you're ready.
I'm ready.
All right. It's coming your way.
All right, hold on a sec. For some reason there we go. All right, all set, Seth?
That looks great. And if you want to give a little bit of a bio for yourself, I
Yeah.
didn't do much of that, so that'd be great to get that
No,
context.
that sounds good. So my name is Pete Littleton. Good morning, good afternoon, whatever time frame we're in right now. And I really appreciate the opportunity to participate on this panel. I work with Corvias, and we are a company that has been doing community-based partnerships for quite some time, specifically focused in stormwater for about the last 5 or 6 years. We started with a pilot program in Prince George's County, and have built kind of a portfolio of projects. We've expanded our portfolio of projects kind of across the US, and I'll go into a little more detail later. My role is I'm on the operational side of the business, where I help build the teams and build the implementation of these programs. So I'll jump right in here and kind of get started. I think what I wanted to share is probably a little different than some of the other panels we'll share, because I would say our perspective is a little unique. We're as I said, it's a community-based partnership, right? And so we partner directly with the municipality around their total need. We help them as far as coming up with a plan of action to move forward and meet usually a large chunk of their compliance goals. So part of our effort is participating in partnership with them to identify the right path to do that, and that's typically through a mixture of goals and kind of measured outcomes. So part of our focus is getting stakeholder buy-in. That's at the individual project level. For stakeholder buy-in as far as, hey, we want to build a project on a certain parcel or in a certain location in the community, but it all goes all the way up to generally in that jurisdiction around getting support for the funding mechanism for the program, whether that's a stormwater fee or some form of funding that the stakeholders generally don't connect the dots related to stormwater infrastructure and the benefits that can come from that level of investment. In most of the jurisdictions, you're making investments that are of large scales, multi-million dollars, some case hundreds of millions of dollars, and making sure the community understands the reason behind that investment, and then also what are the local benefits that you can see. So that's part of their measured outcomes. So as part of our programs, there's typically always going to be the compliance or the treatment goals that the jurisdiction we work with is trying to meet. There's also going to be some what we call social and economic goals, which are related to, if we're going to spend that much money and we're going to do that level of effort in a jurisdiction, how can we ensure and make sure that that money is spent locally? It helps the local businesses, particularly small disadvantaged businesses, and how do we also make sure that the majority of the work is done by the residents of that community? So those are the measured outcomes that don't always come to mind when you think individual stormwater programs, but they certainly are a high priority for county council members, city council members, different groups that we typically work with. As far as innovation goes, innovation can be through technology, but it can also be through the approach and the process in which you're going about doing work differently than a jurisdiction may have done it before, or contemplated doing it before. Next slide is more about a community-based partnerships programs that we manage across the country. As you can see, we've laid out the different ones that we currently have. I wanted to lay out kind of what is community-based, what is the community-based component of it, right? So that's building the stormwater industry capacity in the local marketplace, right? So as we've talked to a lot of jurisdictions and worked with a lot of jurisdictions in the stormwater space, that's been an ongoing problem and an ongoing issue. It is the ability to identify the capacity to do the work, because stormwater and has been kind of a niche marketplace today, and there's a lot of firms that do similar types of work and have the similar skill sets to the type of skill sets that you need to install these types of devices, but they just don't understand and can't correlate the opportunity for themselves. And obviously that ties directly into the local resident workforce development. So as we create capacity within local businesses, obviously they're going to need more employees. So there's an opportunity to create jobs and long-term sustainable jobs at that. And obviously we're, as part of the community, we focus in the areas that the stakeholders of the jurisdiction want us to. So we select locations based off of the treatment opportunities, but also the value that those project locations may bring in other components of their premise, whether that's public outreach, education, all of those different types of things. Performance-based is a little bit more traditional, making sure we're focused on surety of execution, cost and schedule, surety of compliance, making sure the devices that we're suggesting to put in and we build meet the compliance goals related to our partners' needs. And then also there's various options depending on the different partnerships of how we can make working capital investments to accelerate the overall delivery. Here's some successes in the existing partnerships. Like I said, we do a lot of work not only on trying to select the right types of projects and the right menu of services, from ponds to bioretention to stream restoration, all the other different components, but we, as I talk about the community component of our program, here's just some examples of the impacts that we've made locally in both Prince George's County and the city of Chester. The majority of our money, 81%, for example, in Clean Water Partnership, has been invested with target class businesses. That's about $135 million to date. We do run specialized programs around actually taking deep dives with these contractors. We work with the overall contractor base and help them develop and build capacity and see the pathways to where they can get involved in this type of work. But we also do very pointed mentor protege programs where we take smaller businesses that are trying to grow. We really invest time and effort and education into helping them realize that growth. Moving forward, we're going to get into some pond examples. I'm not going to read this word for word, but I wanted to kind of go through kind of our thought process as it relates to ponds specifically. Obviously, ponds is a percentage of our overall delivery in the different jurisdictions, but it's a hugely beneficial deliverable because obviously you can treat a large amount of area. There's a lot of, as mentioned before by the other presenters, there's a lot of existing ponds that can be retrofitted and get some really great benefits out of. Most of the ponds that we come across in our different programs were built more on a water quantity focus rather than the quality. So part of our assessment process and part of the retrofit of that project is obviously adding components that allow us to not only capture most of the sediment, but then easily get in and do the long-term maintenance, right? The technology, these systems, the example here, and then I'll go forward to another example here, Old Chapel Park. These are examples of, you know, they're not high-tech solutions. They're gabion walls that create forebays that allow us to collect the sediment. the technology comes from how we monitor the amount of sediment collected into those forebays, and how we go about ensuring that the forebays are continuously cleaned out. As we're building our programs, all of our programs have a maintenance tail associated with them. So this program, for example, that this pond is part of is our Prince George's County program, where we have a 30-year responsibility for maintenance. So what we want to do is come up with a solution that's really easy for the maintenance crews to come in and address the issues quickly, efficiently, and it's really easy for us to monitor the sediment level so that when they get to the right height or the right depth, that we are able to get the crews out there as quickly as possible and remove those pollutants in the right way. Here's another example. This is Laurel Lakes Pond. It was designed for water quantity treats, but we've been able to retrofit it and provide a water quality treatment to 163 untreated impervious acres in the drainage area. And again, it's another opportunity where we've created a mechanism that we can get in and get those sediments out as needed and as quickly as possible. The other great thing about ponds is not only when you do a retrofit, are you able to potentially bring that water quality function to an existing water quantity pond, but you're also, it gives you the opportunity to work with the jurisdiction and figure out how to armor that pond for future resiliency type issues, where, for example, here where we as we went through the restoration process, we restored the emergency spillway and reinforced it with FlexMat. A lot of times, in order to get a water quality benefit, we're also enhancing the volume of the pond and the capacity of the pond. So there's multiple benefits to it overall. This next example that I want to put forth is a unique project that we have in planning that's kind of hard to come across in a lot of cases, where we are actually going to create a new pond in an existing dry creek. It's hard to get access to this type of property, and we were able to collaborate with a local private developer, and he's actually giving us easement access to put this pond in on his property. It's obviously a benefit to him, but it's also a benefit to the overall drainage area. There's currently 190 acres. We will get water quality control for about 190 acres with this pond. And it's an in-stream pond. Like I said, it's a dry creek bed, but it's designed in a way to allow the water to flow through versus having a typical dam or embankment with an outfall associated with it. Also, as part of this project, we'll do about 456 feet of stream restoration. This last example of a pond here is a unique situation in the city of Chester, where there's not an existing pond. We have an existing park that has some really large challenges with flooding. And part of our solution that we're working through right now with the jurisdiction is to create a large retention basin. But we're going to probably be looking at leveraging technologies similar to what Opti provides in order to control the levels of the pond and get the maximum benefit out of the retention of that facility. So long story short, this is kind of where I wrap up and ask for your questions. The key for us and the investment we'll make long-term in technology is going to be related to the long-term maintenance of these programs. As we build this inventory of assets, it's going to be really important to make an investment at some point at a bulk rate on monitoring the flows and the capture of these devices, so that we can then disperse the crews appropriately and efficiently to kind of maintain these ponds. As everybody's discussed previously, that's kind of the key to reducing the pollutants. So that's my speech. Thank you.
Excellent, excellent, Pete. Well, we've got, we do have some questions. Randy, do you want me to kick this off and do a question or two, and then we'll open up the poll? Okay.
Sure.
So, Pete, if you want to keep your slides up there, that way if there's some
Yeah.
you might want to refer to that so we can keep that going. So the first question that's come in is, can you give some typical ranges for O&M that you guys are either seeing or experiencing or you're planning for in these 30-year timeframes?
If it directly relates to ponds, right? Obviously, every different asset type or device type requires a different level of maintenance. As far as ponds go, depending on the size of the pond and obviously the size of the drainage area, we are going to monitor the forebays and the collection areas very closely on a probably biannual basis. And then as far as what we're planning life cycle, as we're doing our monitoring of the collection of sediment, we're kind of planning out when we think we're going to reach the kind of 50% mark where we'll need to put crews out there to go in and muck out those forebays. So again, it's very dependent on the drainage area overall. And so it can be anywhere from 5 years to 10 years to longer term if we've got a larger facility.
What about the cost, though? I mean, in percentage-wise, maybe of because I think you often hear maybe 5% of capital for an annual O&M cost or something like that. What are you guys seeing, or what are you planning on?
We plan on about a 3% because we're going through a process at scale, right? So we're not building these projects on an individual basis. We're building, hundreds of devices and maybe, 30, 40, 50 ponds at a time for each of the given phases of work. So you get certain economies of scale when we have multiple contractors that are working under unit cost contracts, and we can keep them busy throughout the entire year doing maintenance across all of our devices. So we see definitely a lower cost there. We plan on about 3%, but typically it's a lot less expensive than that on an individual annual basis. The key is to build up your reserve account so that when you get to that 5 or 10 or 15-year period where you need to come in and do substantial work like muck out a forebay or something like that, that you have the funding available to do it then.
Excellent. Randy, do you have any questions? I've got some other questions that have come in. I wanted to pause here to see if there's anything that you had lined up.
Well, I wanted to ask one very specific question, which is, we've used the term P3, but we haven't actually explained what that acronym stands for. It's a public-private partnership, and at least that's my understanding. And am I accurate in thinking that you folks are using private funding mechanisms to help put these projects use as a project delivery mechanism for this work?
You're correct on the definition, absolutely. We do a varied approach depending on the jurisdiction. So some of the partners that we work with, we help them get state funding through SRF or state revolving funds. Some of the partners that we work with, we provide them capital, upfront capital, and they pay for the work as we deliver and as the projects are accepted and turned over. So it's a varied approach. We tend not to refer to ourselves as P3 as much anymore, and more of a community-based partnership, because there's not always that private funding element. And P3s over the years have gotten a little bit of a people typically look at those as like a stadium project or a parking garage project, where a community-based partnership, the types of partnership that we manage, are more long-term and more invested in the local community. That's with the projects being dispersed throughout the community, in small locations spread throughout a jurisdiction, and or through the community engagement and benefit through the contractors and local residents.
Okay. Yeah, and yeah, thanks, Randy. And the poll question that we have has to do with I'm using the term CBP3 because that's the term that we, some of the grant activities that we have or support for our grant, we're focusing on the community-based partnership approach. So Pete, the last question that is, because there's a question about, what is, how does that really work? Because you didn't go into that much detail, which I understand. I understand why.
Right.
But what makes it different? Community-based partnership. I mean, it's things like you mentioned scale as an example, right? You're doing a lot at scale, so there's economies of scale there. But there are other things, and you also mentioned about trying to work with local businesses, supporting local businesses. And I don't know if you want to go back to that slide, but there's other aspects of this which are fixed fee, right? So there's a certain risk that you do. So there are some elements of P3s that you guys do take on, which is taking on risk. You could provide private support, private financing support. That doesn't, but you're kind of agnostic on that, as I understand. So are there some nuances there that you can talk about? Because that's going to set up our poll question, and then we'll move on to the next speaker. So.
Yeah, there definitely are, and I think what's important is it's customized approach, right? Depending on the community and the jurisdiction. You're exactly right, Seth. A lot of times we're going to bring the benefits that the community wants to see, and each community has their different goals. If a particular community just wanted high efficiency delivery, which is closer to what we see in certain jurisdictions, then we are going to set the program up that way, right? And we're going to make sure that the teams and the firms that we put together and the way that we build the program reflects that.
So you mean high efficiency versus social or community kind of, is that you're talking about? So like lowest cost versus providing support to the community, is that the balance we're talking about?
Right, you can have both, right? Like generally it's going to be lower cost overall because of the scale that, as you mentioned, the scale that we're working at, and the fact that we're 100% focused on this, right? Our only goal in life is to be focused on delivering the set scope that we agree upon with our partner, and we operate almost like an owner's rep, right? Where we're making decisions and working with our partner and managing the process and the delivery of the program to get those outcomes that they want. And those outcomes are established through kind of that partnering effort, which is really important up front. It's kind of that, hey, when you're entering into these partnerships, it's really important to establish what are the goals in that local community, right? Is if we're going to spend this kind of money out in the community, what's important to the community? Is it making investments at schools, at faith-based locations? Is it, not every time is it, hey, we've got to do the most cost-effective project or the most publicly visible project. It might be a mix, right? It might be let's take the overall budget, let's make goals that are related to meeting certain components of the delivery and the project locations or the project types, and we'll find that right mix where we can average out and get you the overall performance that you're looking for, while still getting some of those high value components. Example at Prince George's County, some of the high value is they really wanted to see as many installations as possible throughout the county school systems in order to help with the educational components of their permit. So that's one of the areas that we focus on, is finding projects that are high efficiency as far as treatment and low cost, so that we can spend more money at school locations to not only put devices that might not get as much treatment area, but have other ancillary benefits to them.
More social, more community or social impact, right?
Exactly.
And as I open up this poll question, I mean, it seems like what you see oftentimes is even just by being the owner's rep and you're working at scale and all of the features we're talking about like a 30 or 40% cost reduction just by doing those kind of things, right? And then innovation and technologies, that's part of this cost savings, correct?
It is part of it, and it's part of the investment strategy going forward, right? Like as I mentioned, as we build scale with the assets that we develop, then we will make decisions around how we invest the maintenance dollars in order to make the program overall more efficient. And so those may be longer term, those may be investments in technology and different things like that.
Yep. Excellent. Well, thank you, Pete. And while you're finishing up your thoughts there, I opened up a poll for everybody, asking folks that are involved who are here with us to characterize your familiarity. Is this type of program something that's entirely new to you? Is it something that's kind of relatively new? You're aware of it, but you only have a kind of a superficial understanding, or is it something that is familiar? You have a good understanding, and more than just superficial, or is it something that you're very familiar, thinking about doing this, really curious about it, and then the last is we're already implementing this type of program. So I'm just kind of curious about where folks land. Randy, do you have any thoughts to share this?
Well, I had one other question for you, Pete, which is, it appeared as though there were really significant regulatory drivers in all the examples that you offered where you're doing these sort of projects. That you were looking in the 50 mil to $500 million range. Is that sort of regulatory driver at that type of scale typical and necessary as a driver for this type of work?
I would say there has to be a certain amount of scale, but I think there's a ratchet up process to it. For example, in Milwaukee, our initial phase is about $20 million. I think in order to meet a lot of the jurisdiction's overall goals, you have to have a certain volume associated with that, right, to make the impacts necessarily in this type of program.
Okay, thanks.
Thank you.
And I'll just share the what we've seen here. So it seems like most people have some awareness of this type of program and approach, but only in a kind of superficial, very limited way. And that's not entirely surprising, frankly. So thank you for that feedback. And again, we're going to be asking for more of that in the future. So I will hide this. And so the next presenters we have are Bob Hawley with Sustainable Streams, and we've got Matt Wooten with SD1 talking about retrofitting ponds to promote hydrologic restoration and geomorphic recovery. So Bob and Matt, are you ready to go? If I send you the screen share?
Ready.
Excellent. Okay, I'll send it your way, and you can take it and go with it.
Okay.
Yep, make that flip and you're good to go. Great.
All right. Well, good day, everyone, and thanks, Pete, Seth, and Randy for the great presentations. It's good to be with you, and my name is Bob Hawley with Sustainable Streams. We're a company that really just specializes on stormwater management and stream restoration, trying to move the needle in the stream with that kind of 1-2 punch. And with me is Matt Wooten from SD1 of Northern Kentucky, and I'm going to let Matt introduce himself, and he's going to kick off the presentation.
Great, thanks, Bob. Again, my name is Matt Wooten, Northern Kentucky Sanitation District No. 1. We are a regional storm and wastewater utility in Kentucky and the second largest in the state. I'm going to start things off here just by giving you a little bit of an idea of how this is going to flow. I'm going to talk about the background of this whole program, kind of how we got started and where we went, that led into the monitoring approach that we've established over the years. And then I'm going to turn it over to Bob and talk about more of the approach and the applied side of things, and then wrap things up with our next steps. So I like to ask this question a lot, especially when I'm talking to groups like this, and I'm kind of happy to say that the answer that I typically get has sort of evolved over the years. Usually when I would say, why do we manage stormwater runoff, I would get a lot of people screaming because the regulators make us. And that's not necessarily the answer that we're looking for. Now we're beginning to understand that, stormwater has a real impact in streams. And so we need to start thinking about it differently. So, you know, historically, we were looking at a flood control component. We realized quickly that as landscapes changed, we've seen, you know, flooding issues downstream. Originally, you know, early on, it was a narrative approach, just kind of a paragraph on what we should do, which kind of led to sort of the presumptions of if we do X, then Y will happen. And we use things like design storms, and we still do, and those are effective. Those are all theoretical and maybe not exactly tailored to what we need. Now, early on, there was really no consideration of things like water quality when it comes to stormwater management. That's been a fairly recent component. And even more recent is looking at things like channel protection. Can we reduce erosive flows and incision and things of that nature? Or just taking into the context of just what can we manage our stormwater for an overall stream integrity approach, looking at the ecology and the hydrology and things of that nature. It's interesting that we go that route because it's been quite a while since stormwater runoff has been established as one of the most serious threats to our streams and rivers. So we kind of have to wonder why. If it's been a while, you know, then what's taken so long? If we look back, we can see that again, just sort of putting the pieces in place. A landmark paper in 1997 was from Dr. Leroy-Poff that was titled The Natural Flow Regime. That kind of set the stage for a lot of programs in place now. That paper was published in '97, has nearly 7,000 citations since that publication. You know, that led into something called the urban stream syndrome, which was by Chris Walsh and several others that basically said the characteristics that we're seeing from these urban systems due to stormwater management are so ubiquitous that we're going to give it a name. Kind of led to some further work, and that maybe suited more for the practitioners, the applied side of things. When you look at things as a stream function pyramid by Will Harmon in 2012, and this was one of the things that kind of got my wheels turning and kind of got things moving inside my agency, that, hey, maybe this is the approach that we could do, because as the stormwater utility and as we design and requirements and performance standards for stormwater controls, if we keep the hydrology in mind, we can reduce the impact. If we can design our controls such that we're mimicking or matching hydrologies, then we can have a positive impact throughout the stream as it moves up the pyramid. So you kind of have to wonder what's taken so long and things of that nature, some of the barriers that we've dealt with over the past. You know, we've heard a lot about different things, and a lot of it has to do with, you know, the lack of a goal or a target or a threshold. You know, we didn't have that exact number to manage toward. It was more of, again, it was a theoretical design storm that this should work. And, you know, that was part of the problem. Regional variability was something that we didn't take a lot of consideration of. Historically, we've looked at stormwater management more of a, you know, sort of a broad brush approach, sort of a one size fits all. And that can lead to problems too. In my own state of Kentucky is a perfect example of that. And mountains in the east and swamps in the west and everything in the middle between there, it stands to reason to think that, you know, the management practices for the mountains maybe wouldn't be as applicable in the swamps. So we have to think about the regional side of things. We have to think about the baseline condition. If we don't know where we are, we don't really know where to go. So we really have to understand how the streams in our systems are reacting to stormwater runoff. And then there's other complexities that we've heard mentioned already today, the social side of things, getting folks to understand why we need to manage the stormwater, you know, why we may need things like a stormwater assessment fee, which leads into the financial side of things, you know, getting folks again to understand these kinds of things don't happen for free. And then unfortunately, there's the political side of things, because rarely do we get policy development without politics being involved. So we have to do a really good job of talking to our elected officials and making sure that, you know, things that they're doing, like political appointees that help manage utilities and stuff like that, really understand what's going on behind these decisions. So how do we get there? Well, to answer all these questions, we decided we'd collect data. We would collect data to inform our decisions. And that led to the establishment of our stream assessment program. It's one that I'm personally very proud of, and I think is one of the most comprehensive in the state of Kentucky. We've got over 75 established monitoring stations now, in the 3 northernmost counties of our jurisdiction. We have been collecting data now for a little over a decade. Includes water quality parameters such as things like bacteria and suspended solids and so forth. We're looking at biological data, bugs and fish, physical habitat, RBP scores, rapid bioassessment protocol scores for every one of these sites, as well as a stream stability component, which is something I think is fairly unique to our program and something that we've taken to the next level. Okay, Bob. We took all that information to establish our baselines. Again, we needed to know where we were in order to know where we were to go. We have been able to document that streams are becoming more unstable as watershed imperviousness increases. We're seeing the same kind of trend within our biological communities as we're seeing our biotic indices go down as impervious surface increases. Again, these are well-established trends, but in order for us to really demonstrate that we're doing a good job, we need to establish in our region as well. Even more obvious in those baseline conditions, you can see within the biological community structure, the 2 circles you see represent 2 completely different communities. One is a rural community, sort of a reference condition, and the other one is a very urban condition. So you can see that there's definitely an urbanization gradient within the biological communities of our receiving streams. We needed to establish the thresholds I mentioned. If we do want to have a program such as this, we need to understand, okay, well, what is that threshold? That introduces the critical flow concept. Where's the point in our streams that the bed load begins to move around and the banks begin to erode? And we've been able to do that in northern Kentucky. We've established the relevance of those programs. We're seeing things like riffles getting shorter and pools getting deeper, which we know can be detrimental to both the habitat evaluations as well as the biological communities that live there. And making even further argument for the biological relevance of the approach, we kind of stumbled into an accidental experiment a few years ago. In 2011, we had a very, very wet year in northern Kentucky, double the amount of precipitation that we typically get, coupled with some very large events mixed in there. Our best reference stream, which always produced very high diversity and very high quality index scores, reacted as though it was an urban stream that had communities that was more similar to what we see in our urban system. However, in 2012, when precipitation patterns returned to somewhat more normal, the stream recovered. And we're not seeing that recovery in the urban system, which makes it even a further argument for trying to work with the hydrology within the system to restore the streams.
Excellent. Thank you, Matt. Matt set the stage really well, and I know this webinar is on ponds, but this sort of baseline background info is really important for this setting. One of the things that you all will not be surprised about, take this watershed here, Dry Creek, and the relevance to the politically appointed board members, for example. An unstable stream is not ecologically beneficial, but it's also not even in the best interest of the sanitation utility. For example, here's one of the main trunk sewers at the SD1's jurisdiction, and over 40 years of down cutting about 5 feet or so at this location, and you've exposed the stream and made the sanitary sewer at serious jeopardy of potentially failing and causing a direct discharge to the stream. So once unstable streams started impacting SD1's assets, then it became even more clear that the financial relevance in terms of managing stormwater to prevent these down cutting trajectories and bank erosion and channel instability in general. In terms of water quality, we see that of course, we measure for everything, but bacteria and sediment are by far the number 1 and number 2 pollutants in our developed watersheds, and sediment in particular, up to 65 times benchmark loads in some of these developed watersheds, and we have pretty good evidence that a large majority of that sediment is coming from bank erosion the stream banks as instead of the catchment. Matt mentioned some of the trajectories we're seeing in the stream. So habitat homogenization and bed coarsening is one trajectory. Here we see shifting bed material over a 4-year period. The D50, the medium particle, went from 1 inch to about 16 inches in over a 4-year period. So coarser particles, a kind of less well mixed particles, and less diversity and less niches for some of the critters that live in these streams. So Matt's monitoring program established pretty well here that conventional stormwater designs were leading to unstable streams. Here are 2 sites that are very similar drainage area. The only difference is the imperviousness, and pictures say 1,000 words, but so does the cross-sectional surveys. You see the suburban stream, 9% impervious, is about 9 feet to the floodplain. Middle Creek, our reference site, is only about 3 feet to the floodplain. And Matt already mentioned this, but we see a very precipitous drop-off of EPT richness. That's the mayflies, stoneflies, and caddisflies, the more sensitive species. Once we get above 3% impervious area, we see pretty clear impacts to these taxa. But then above 10%, and we've pretty much bottomed out. And so it's clear that conventional stormwater management is not protecting stream stability or aquatic biodiversity. And so again, getting back to the idea of ponds, first it's important to remember the history of stormwater management. So let's take a pre-developed flow regime. This is the 2-year discharge as an example. Pre-1950s all the way up to the 1980s or so, you develop the watershed, you add your roads and your houses, and you route that stormwater as quickly as possible to the nearest creek. So all that extra volume has resulted in an increased peak. And that led to flooding downstream, and engineers, we scratched our heads and said, this isn't good. We're supposed to protect the public. How do we stop that? And so we came up with this idea of peak matching. So, you take that extra volume, you route it into a detention pond, and, you hold it back so that you're not exceeding the pre-developed peak discharge for a given design storm. But you see here, you've got a lot more volume, right? That you're releasing at those kind of relatively large flows. You look at most stormwater ponds, especially the dry detentions, and they're almost always dry, even during rainstorms. Yes, I do use my kids for inspecting basins sometimes, but anyway, the reason that they're mostly dry, even during events, is that they're typically sized for and their outlet constructors are optimized for regional flood protection. And it varies by jurisdiction, but in Kentucky, that kicks in at about 3 inches of rain. And of course, 99% of the storms in a typical year, are much less than the 2-year discharge. And so, you take a very small event, 0.3 inches in 1 hour. This is what it looks like in a developed watershed, about 30% impervious. This is what it looks like in an undeveloped watershed, a very similar rainstorm. And so, folks have criticized us. They said, "Hey, it looks dry. It looks like a sunny day. Are you just tricking me, or is that what's the deal with that picture?" And actually, this picture is taken at peak discharge about 3 hours after the rain had stopped. So what happens in an undeveloped watershed? The water infiltrates, hits the leaves, slowly makes its way to the topsoil, and then in Kentucky, where you've got a clay subbase, it hits that subbase and then seeps down the slope, and then eventually makes its way to the stream about 3 hours later with this little blip in the hydrograph. Of course, I'm sure lots of the pond webinar has focused on water quality concerns, and going back 20 so years ago, that was a big deal that ponds were not dealing with, and so this idea of the water quality volume kind of came into fashion in the 2000s or so, and taking this idea of let's take a reasonable amount of water, say 80 or 90% that captures 80 or 90% of the storms in a typical year, and get it routed through some sort of treatment. So you take a detention pond and you put a sediment forebay on it, and you size the outlet structure to be kind of a extended detention basin, and kind of like some of those Gabion retrofits that we saw from Pete in terms of knocking down the sediment load. And you know, they take various forms. They can look very pretty, and they can really fit with the community. You know, what their goals look for at a specific location. But in terms of channel protection, the zone where channel erosion often begins is often in this unmanaged zone of rainfall. And so let's get back to that critical discharge. Matt mentioned it earlier. It's really the discharge at which, you know, above that discharge, you are mobilizing the material on the bed. And so in this system, in this kind of hypothetical system, here's our critical discharge, this dashed line. This is our 2-year storm. And you see the volume of water above that critical discharge, and you compare that from the pre-developed condition to the no detention condition to the conventional detention condition. You see even the conventional detention peak matching condition, we still have a lot more time that is leading to, that is exceeding that critical discharge and leading to more erosion than the pre-developed condition. And so excess erosion of the stream can lead to stream deepening and widening, water quality impacts, biological disturbance. So, you know, you imagine you continue to do this over and over, the particles get mobilized, they're not being replaced from particles from upstream, and you have your original stream bed, and over time you've scoured out those particles, and you basically created a deeper and wider stream bed. This trajectory of instability we've seen across the U.S. really. You know, you take an equilibrium channel that's got a good connection to the floodplain, you mobilize those particles on the bed too frequently, they're not replaced from upstream, and all of a sudden you've made it deeper. As you make the stream deeper, you make the banks taller, and then that leads to bank failure and widening. And you know, you need to have a lot of widening and kind of flattening of the slope before you start to see deposition of that material and aggradation, and then eventually a return to equilibrium here. And so, the importance of Q critical, as Matt mentioned, is even evident at reference sites. He mentioned this slide earlier, but just kind of to put it a little bit more simply, MBI, basically the biotic integrity of the macroinvertebrates, basically a measure of biotic health here, that increases with the number of days since a disturbance event. So the longer period you have since a Q critical disturbance, the better your MBI are at this reference site, right? So biotic integrity increases with increasing recovery time. Channel enlargement basically decreases with days since disturbance events. So the more time you give a stream between disturbance events, the more time you have for geomorphic recovery as well, and sort of the processes of bar building, colonization of the bar by vegetation, and so forth. So Q critical is clearly relevant geomorphically and biologically, but there's a lot of scatter in these data. These data from California, Australia, and Kentucky. We have a really good trend that's plotting Q critical as a fraction of the 2-year discharge versus D50. Really nice trend, but you know, we've got basically 3 orders of magnitude at any given D50. So it's really important to calibrate that Q critical to your region. In Northern Kentucky, that management value is about 0.4 times the 2-year discharge, the pre-developed 2-year discharge. And so we take that, and now it's a matter of piloting some retrofits. And so we're going to take a hydrologic restoration example, a detention basin retrofit example that SD1 and Sustainable Streams piloted with US EPA and Boone County Conservation District and a few other partners. Here's the before outlet. Here's the retrofit outlet. So you take a 24-inch outlet that was the low flow outlet. We've choked it down to about an 8-inch opening. And then, you know, that basically restricts the every given, you know, any given day precipitation. And then we've got this passive bypass that allows flows to, during, you know, the larger events to get out and access that entire 24-inch diameter orifice for those larger events, so that we're not really increasing the risk of overtopping during, you know, the 100-year events, for example. As I mentioned, a lot of partners on this one. This passive device here, they call it the Detain H2O. It is patented, co-patented between US EPA and Sustainable Streams. We've written up a manuscript about it, but here we're just going to show you some examples. So simple change in outlet structure, an event that probably would have passed right through, barely ponding to the top of the original orifice here. But because we've got that restricted outlet in, we're holding back that water and allowing for sediment to settle out and so forth. In terms of the critical discharge, here we have our pre-retrofit outflow. Here we have our post-retrofit outflow. Our critical discharge at this site is about 0.38 cubic meters per second. And so pre-retrofit, even our 3-month storm was exceeding the critical discharge. So every 3 months on average, the bed in the stream downstream was getting disturbed. After the retrofit, it's no longer being disturbed for the 3-month, 6-month, or even the 1-year event. So now we've got basically up to about a 2-year period of recovery between disturbance events that are no longer exceeding Q critical downstream. So an example hydrograph, take a peak inflow of about greater than 20 CFS. We've restricted it to be less than 4 CFS, and here's some pictures that track with the hydrograph. So we get the big flush coming in. You see it's dirty, loaded with sediment, right? Giving that sediment time to settle out. Potentially more UV exposure and so forth. And then after about 3 hours of extra ponding, then would have occurred under kind of the inflow equals outflow condition. The peak continues to go back down, and then we got a very prolonged kind of trickle release, through that kind of wetland vegetation that's established in this basin. We have receiving stream data downstream of the site here. So here's our basin. Here's our huge facility that we're draining, and we've got the immediate receiving stream called a spur, an upstream control site, and then a downstream site. And both for our we've got a pre-retrofit period and our post-retrofit period at each of these. Here's our high flows and here's our low flows, sort of the 90th to 100th percentile flows. And what we see here is that our upstream site, the post-retrofit period got worse in terms of the erosive events, but it also got drier. And that was simply a reflection of the rainfall. Nothing changed upstream of the upstream control site. At our spur site, our post-retrofit high flows got smaller, and our post-retrofit low flows, they were extended. So it went from going dry about 10% of the time to having pretty much permanently wet pools. So that's totally attributable to the retrofit. And then our downstream site, it's basically a wash. And so what that says is, even though the post-retrofit period, the rainfall became more erosive, the effects of the spur basically wiped out the more erosive rainfalls at the downstream site, so that they're basically equivalent. So we're seeing fish in these pools in a system where we never saw fish before. So we're seeing that biological lift that Matt talked about earlier. In terms of our sediment, we're seeing continued coarsening of the bed material at our upstream control site. We're seeing aggradation at our spur site. And then, kind of at least for that initial period after the retrofit, we saw basically equivalent bed material at our downstream site. In terms of bank stability habitat, here's our spur before. Looking upstream, you see kind of vertical, raw banks. And then after, we see a bench that's getting vegetated here along the toe of that bank. We're also seeing more wood being retained in the channel, and kind of a more establishment of kind of a low flow meandering channel in the spur site. Looking downstream at our downstream site, again, pre-retrofit, we saw vertical eroded banks, a tree with exposed roots. About 6 years later, we see a bench that's formed, that's vegetated. We no longer see the exposed roots of this tree. Our bank stability has improved, and again, we're seeing kind of more of a meandering low flow channel instead of a kind of totally over widened chaotic channel. And that, again, pictures do a good job of telling the story, but that trend at the downstream site was also captured by repeat surveys. Here we see the sediment bench that was developed at the surveys at the downstream site, and then again that was eventually colonized by vegetation. And then at our upstream control site, here we have pre-retrofit, a vegetated bench, decently vegetated banks, and then after the, about 6 years later, we don't really see the benches anymore, and we do see bank erosion at our control site. So basically, the upstream site continues to get worse. Improvements at our spur and our downstream site. So again, habitat recovery, RBPs from the poor range at our spur and our downstream site before, and they've basically been bumped up to average in terms of RBP. So much more wood retention, much better bank stability, and then kind of a more concentrated low flow channel instead of that sort of over widened condition that doesn't hold very deep water generally. So we basically saw this trajectory from stage 3 at our downstream site to an aggradational period for about 5 or 6 years to the benches actually being colonized by vegetation. And so we're seeing this transition simply due to that hydrologic restoration upstream. So we have since looked at many detention basins to try to do this at a larger scale. So here's an example of one of their watersheds at SD1 where we got very poor stream conditions, draining lots of detained areas, but they've all pretty much conventional detention. And again, opportunities for retrofits. And we see we've been developing this methodology with input from the Army Corps of Engineers that if we do this hydrologic restoration, we have the potential to bump these streams up from poor to average. If we couple those with conservation easements along these stream corridors, if we couple them with potentially some wood being added in the stream, we could generate up to 3,000 to 6,000 stream mitigation credits, and basically start reinvesting some of those mitigation dollars that developers pay in Northern Kentucky, reinvesting those into paying for hydrologic restoration and stream corridor conservation within the same jurisdiction. So with that, I'll hand it back over to Matt.
Yeah, just real quickly to take the scaling up idea to the next step. SD1 is so encouraged. We're so encouraged by the results that we're seeing in stream from even these small scale retrofits that we took the opportunity to inventory our entire service area for the existing basins that we have, with the idea that we're going to start proactively retrofitting the basins and bring them up to our current performance standards. We got over 2,300 basins in our service area alone, and we've looked at the top 10% of those, and we are beginning to prioritize those right now. And in fact, I just awarded the first contract a few weeks ago to go out and begin the early retrofitting. And to just real quickly parlay a little bit more about what Bob said, we've been, for several years now, we've been in discussions with the Army Corps of Engineers about the potential of hydrologic restoration being used for mitigation credits. And after basically walking them through this program and keeping them engaged to the entire process, they have sort of blessed us with moving forward and trying to create a mitigation bank in one of our most urbanized systems that's steeped in this idea of hydrologic restoration. So we're having a lot of luck, and we're really looking forward to what this program has for us in the future. And with that, I think that wraps us up.
Okay,
yes.
Thanks, Matt. Thanks, Bob. You guys covered an absolutely insane amount of information, and we do need to get going. I've got there's a number of questions have come in. I was going to throw one out there that came in, and then we'll have more time for everybody at the end. And then Randy, maybe you can wrap on over the next poll here. But one of the questions is, well, first of all, there's interest in the links that on your research, Bob. I assume that, I don't know if you've got that available. If you've got that available, then and you're free to share that. You can send it to me, and I can send it out to everybody else, or however you want to do that. So that's just a thought.
Yeah, and the PDF has links that work too. So if you post
Okay.
the PDF presentation, yeah.
Okay, great, thank you. But one of the questions is, do you have any experience or reservations regarding installing a detention basin offline along a stream? The inflow would be the stream during the large flows, and the discharge back to the stream during, I guess, non-flow. So is that a clear question to you?
Yeah, we call those basically bankful wetlands or off-channel habitats, lots of different names for those. But when we're trying to retrofit suburban watersheds already developed, there's not a lot of room often to work at the scale we need to work at. And so floodplains that are undevelopable anyway are often a good place to put like a bankful wetland or some sort of detention feature, glorified detention feature. And that's an idea that U.S. Fish and Wildlife has really got behind, and also OEPA in terms of the nutrient reduction benefits as well as the habitat expansion, in addition to knocking down the hydrograph.
OEPA is Ohio EPA.
Yes.
I just want to not to get too acronymed out. Okay, well, I'm going to share a poll real quickly. Going to ask folks to answer this quickly because we do want to get on to the next topic. And Randy, I don't know if you have any thoughts that you want to share as we launch this poll right now. And we're asking basically, how familiar are you with this type of approach in your community? So, and Randy, any thoughts you want to share, questions you want to ask?
Well, I wanted to ask one quick question, which was, it seems clear that a driver, but also payoff for all this work is improvements to stream health and bank stability. I'm wondering what the regulatory drivers and payoffs are for this work.
Yeah, I might let Matt take that one, but just for reference, Kentucky is not quite as far along as like Chesapeake Bay is in terms of kind of regulatory requirements of their MS4s in terms of where they are in their program and what's required. And so, like Matt said, this is really a proactive approach by SD1 at the moment. They don't really have a thou shall implement this or retrofit this much impervious area by a certain date. This is more of a proactive, kind of in the best interest of not only the streams, but also the board and kind of fiscally, for asset protection. So.
Yeah, I think just to take that one quick step further, I think that's, while we're not quote unquote bound to this approach, I think one of the reasons that the Corps of Engineers blessed us moving forward with an urbanized mitigation bank, where they've been very reluctant to do so in the past, was the fact that we have established this and the relevance of it, and that we can actually have ecological lift to do a lot of these things. So from the regulatory side of things, I think that really it's a trust type of issue.
Interesting. Thanks.
Okay, well, I'm going to close that poll, and I'll share that with everybody so you can see what the results are. It looks like most are considering a program like this, and also a good chunk of folks, a quarter or so, just don't have the resources at this time. So does that surprise you guys, Bob and Matt, just real quickly?
No, I hear that comment fairly frequently, and I think one of the papers that Bob references was trying to help programs such that they can use some of the information that we have to try to begin to tailor an approach to their own systems. You can correct me if I'm wrong, Bob.
Yeah. Basically, we've got regulations that require lots of things, but flooding and erosion tend to be top concerns of a lot of stakeholders, and so kind of giving MS4s the tools to connect, stormwater management to not only flooding but also erosion prevention.
Yeah, great.
Seth?
I do have, yeah, Randy.
I don't know about everybody else, but I'm not seeing the poll results at the moment.
Oh, I'm sorry.
I'm seeing the slide.
Yeah, I hid them. I'm sorry. I will.
There we
share
go.
them. I'll share them again. Sorry, I was trying to transition away. We do need to move on, and we do have some questions that have come in. I also have some questions I want to ask you guys about costs too and cost effectiveness. But we're going to move on now, and I'm going to ask Scott Struck. Are you are you good to go with the next presentations? Oh, there you are. You
Yeah,
are ready
thanks,
to
Scott.
go.
I'm
All right.
I'm ready.
So
Just
Scott,
share
Scott's right.
away.
All right, and we, I know we're a little bit adjusted, but keep on. We got time, so take your time. All right. So I'm going to share my screen with you, and there we go. Okay, so Scott and Chris are gonna talk about technologies from across the country, I believe, Scott. Tell me if I'm wrong, and hopefully you're
Yeah, that's right. Sorry,
excellent.
it came up, Seth, but I'm not.
Nope, it's there. You got it. You're good to go.
Okay, there we go. All right, show screen. So
Yep,
showing
you're
this
good.
one. Okay, everything looks
Well,
good.
no, it was showing the screen. Oh, no, that's back. Now it's back. Yep, good
Okay.
to go.
Great. All right. Again, good afternoon or good morning for everyone. Thanks for having me, Seth, and it's a pleasure to be here. My name's Scott Struck. I'm in the Denver, Colorado area. I'm a principal with Geosyntec Consultants, and I do primarily, municipal stormwater type of work all across the U.S. and even across North America. I do several projects up in Canada as well. And today I have with me my colleague, Chris Wessel. Chris, why don't you do a quick introduction of yourself?
Yeah, hey all, thanks Scott. I'm Chris, colleague of Scott, as he mentioned. I'm based in Los Angeles, and most of my focus, similar to Scott, stormwater infrastructure, municipal planning and design for stormwater purposes, but most of my focus has all been here in Southern California. So Scott and I are going to kind of tag team it a little bit, and I'll present a few projects we've been involved with here in LA and Southern California, and Scott will hit on more of a national level. So I'll turn it back to you, Scott.
All right, thanks, Chris. All right, so with this, I think we can cruise through some of the beginning stuff, but one of the things I wanted to hit on with this was really that part that I think originally Pete brought up in terms of understanding the original design and goals and expectations of our stormwater systems. I thought Bob and Matt did a great job of going through some of that history and that evolution that's happened. I do want to hit a little bit on what both of them actually had talked about, and that's this idea of understanding where the current our current assets are in terms of an inspection and asset management, which is what Seth is really talking about at the beginning in the introduction of the session. So, and then we're going to focus really on these technologies to meet new stormwater infrastructure expectations, and then share some case studies, as Chris just said. So with that, as I just mentioned, recognize that our goals and expectations of stormwater infrastructure have evolved. I thought, again, Matt and Bob did a great job talking about how it's changed from what was done essentially in the 80s and 90s in terms of just starting the water quantity, well, mostly the water quantity side of things, and kind of going towards water quality in the 90s and 2000s. And really, so we've moved from just really kind of this kind of peak flow to more of a flood control. A volume capture is often included in many jurisdictions, getting what again, Bob and Matt were talking about with the channel protection and flow considerations. Of course, water quality is a huge driver for almost all municipalities. And then some are even getting to this notion of resiliency and able to, the ability for our systems to respond to large events, but actually also recover from large events so that they're still functional afterwards. So thinking about that and thinking about how we have to get or make our infrastructure evolve with these changing objectives and these design parameters, I think is an important concept to keep in mind. And then if you throw something like climate change into this whole aspect of a lot of our systems are designed, Matt was talking about, design events and so forth, and whether some of our design events, which are often built around historic information, whether those are still applicable in long term, and how these things have changed. So a lot of us are updating to, for instance, NOAA Atlas 14 type of more recent information that updates our design events, but also looking at that continuous simulation and then projecting forward for instance, downscaling some climate change models and how we might use that kind of information in the future to help, again, try to determine what those design objectives need to be for our future infrastructure. And this is typical of what we see in a lot of locations. It's certainly present here in Denver, and I've seen it all over the country, where we have this change in our watersheds, not just from new development, but a lot of times we have infill and redevelopment that's occurring. And these changes in impervious area, both with our new infrastructure and our changing existing infrastructure, it really has effects that look something like this. This is a great example where these houses that were originally these small single-story, relatively small footprint for the impervious area is converting over to something that's much larger, and then even into perhaps something that looks more like this, where we're getting less even front yards and really increasing that impervious area. And again, Matt was showing what those changes do for that impervious area on our streams, and we know that there's a real documented impact of changes such as this. And so with that, we have to change and manage our control systems. The challenge with the redevelopment is oftentimes this is happening on a lot by lot scale, or maybe a small, several lots at a time, but that doesn't give us the opportunity to change that existing infrastructure that's already there that was sized for a different type of footprint. And so we see that the infill and redevelopment presents its own challenges in that case. So to that inspection and asset management side of things, really knowing where we are for what our infrastructure can do and can't do. And that's, again, what was the original design? Was it designed for instance, like a 2-year event or larger, just peak flows? And then determining what enhancements need to be done to retrofit that. So obviously this is a discussion about retrofitting these ponds and different stormwater infrastructure to meet those goals. So understanding what can be done for that, and that's where we'll get into the technology side of things. And then, just the asset management program in general, understanding the history and the facility of areas, the drainage areas, the lifespan of those original systems and how long they're supposed to last, getting to what Pete was describing with the CBP3s, knowing where they are in their lifespan to know if the retrofit is necessary or if it needs to, if it can wait a little bit longer, et cetera. It's really a big part of this. And so getting back to that whole asset management side of things for ponds, I think it's a critical piece of this that feeds into all of what each of us are talking about today. Now that expected outcomes. So I think one of the challenges that we are all facing from the municipal perspective for our existing stormwater infrastructure is we're asking it to do so much more than we asked it to do before. We've already talked about flood control, water quality. Again, Matt and Bob were just talking about the receiving water protections, the geomorphic conditions, ecological support, floodplain and groundwater connectivity. Chris will be hitting on a little bit more about that support, for instance, for groundwater supply and connectivity, which is a big problem or a big consideration for us out on the west side of the country, where we're also trying to consider how we can replenish those groundwater supplies that have been diminished over time. And then those indicators like were just discussed with watershed health. I think the rapid bioassessment protocols with your invertebrates are a great example of how we're looking at something like that. But we're also looking at a lot of our facilities now to not just be stormwater management and tucked off in the corner. We're actually asking them to be a part of our recreational opportunities, having trails around them, having access and so forth. And so that needs to be a consideration as well. So we'll hit on a little bit of that as well. So with all of this, this is probably dating myself a bit, where we're going back to how can our stormwater infrastructure provide all of these multiple benefits, especially when we're being asked to retrofit these, and we're not starting with a blank slate, for instance, for new development. And so it reminded me of this, the $6 man and the bionic woman, in that we can rebuild him. We have the technology. Well, we have for the retrofit of our stormwater ponds, we have the technology, and that's what we wanted to talk a little bit about today. We've talked a bit about the objectives. We have some cool ideas and techniques that are coming from what Bob was really discussing with those passive controls, and we'll hit on some other things that go along with that. So we really do want to build this, better, stronger, faster, which maybe is more like higher performing, greater surety of compliance, cheaper to manage, having public access to it so that people can enjoy these spaces and so forth. So we have to add all of those into this. So some of the technologies that I've kind of mentioned or hinted at are everywhere from something that's really relatively simple, leveraging treatment trains and unit processes. Again, Bob was talking about this great opportunity to retrofit our outlets for a lot of our ponds, and that we're going to talk about as well, but also including that retrofit with other types of technologies. There were several examples given in both the Kentucky example and then with what Pete was describing too, with the 4 bays and so forth. So really taking advantage of that. Looking at additional treatment locations, I think that it was great that Pete was showing where some of those opportunities to bring on more opportunities to bring greater treatment area into these systems is also something that needs to be looked at, and they've really focused on that for the Prince George's County opportunities. And so ultimately, one of the technologies we're going to highlight, and again, Pete mentioned this one, was using these automated or real-time controls to get at each of these types of objectives. So with that, Chris, why don't you tell us about Legacy Park in Malibu?
Yeah, thanks, Scott. Yeah, Scott kind of already mentioned this, especially here in LA and Southern California in general. We're really driven by regulatory water quality, requirements. And so when we talk about ponds, lakes, reservoirs, and really altering those for water quality purposes with usually really minimal space, we're often talking about having to figure out what can we add to treat water, given this circumstance. And so just wanted to share a few of those examples that we've, again, been a part of. There's one here is Legacy Park in the city of Malibu. For those familiar with Malibu or not familiar with it, kind of the northwest coast of Santa Monica Bay and LA. And Malibu is really low density residential spread out across the coastline. But the center of the city, really where City Hall is and the library and kind of their most centralized development, commercial development, is in this area you're looking at, which is just east of Pepperdine University. And there are heavy TMDLs here for bacteria and nutrients especially. And the drainage from about 330 acres here of this area discharges to the east into Malibu Creek, which then spills out into Malibu Lagoon, which then spills out into the Pacific Ocean here. So a lot of focus on this area in particular, and some really, again, significant water quality issues. And what the city did is they looked at this parcel of land where flows were coming and said, what can we do with this to really improve not only stormwater quality and capture, as well as dry weather runoff quality, but resiliency with respect to irrigation. And so they built Legacy Park, really neat park. I'll try to keep this short, but a park that drains about 330 acres. They designed, we helped them look at kind of what is the optimal pond size you could get, coupled with then a treatment facility, ozone disinfection facility that could work in partnership together to help them meet their downstream TMDLs. Scott, you could jump to the next slide, please. And so Legacy Park is basically, again, you can see in this aerial, and then here's kind of a close-up artistic rendering of it. Water comes in from the northwest there through a bioswale, so you get some initial vegetative treatment, and it enters the pond, at which point you have a recirculation line to this ozone disinfection system. The disinfection system can operate at about 3 CFS. They were seeing stormwater flows of greater than 30 CFS on really big storms out into Malibu Creek. So a pond has been designed to really allow them to capture those flows during storm events, still get treatment. Even in large storms, they can treat and discharge out to Malibu Creek, but in dry weather conditions and lower storms, they actually are able to treat and then put it back into a subterranean holding tank, and then they use that water for irrigation of the park. So again, really neat system, and you can actually go to the next slide here, Scott. The park itself, beautiful centralized park for the city of Malibu with some really neat, multi-benefit purposes, educational stuff there, coastal habitat restoration. But kind of a way where we kind of tell people about the project to look at is you get basically 8 acre-foot of storage 2.6 million gallons in this pond, and you got kind of this 4 acre foot, the lower half, if you will, kind of regularly used for recycling and irrigating the park itself. The demands there balance out really well. And then you have this additional 4 acre foot of storage for stormwater flows in that area. And this has actually been a tremendous project for the city and has helped them, allowed them to really meet their TMDL loads in this watershed. So really a neat project. For the sake of time, I'll just keep moving. I know we have a lot of projects. Another one, this by the city of Los Angeles, Machado Lake. Actually, it's the largest native riparian forest and freshwater marsh in LA County. It's a little bit of a hidden gem in LA. It's surrounded by industrial development and high density residential development, kind of in the South Bay of Los Angeles, just north of the LA and Long Beach Harbor there. It drains over 22 square miles. And as a result, really, of all the urban runoff that this lake receives, really heavy pollutant loading, significant TMDLs here for toxic sediments, for nutrients as well. There's algae issues there, odor issues there. So again, pretty significant concerns here over the historical loading that has taken place there over the years. And so over the last 5 to 6 years, the city, as well as some of the other adjacent city partners, have done a lot of work trying to clean this lake up, restore the park around it, and really make it a recreational area for people in the area. And Scott, you can go to the next slide. Actually, the lake itself has a number of items have been done to improve the water quality of the lake, and that includes 240,000 cubic yards of dredging and removal of bed material, an aqua block cap, kind of a bio cap along the bottom of the lake itself, the 40-acre lake. They've installed things like hydrodynamic separators and some other amenities around the park to help improve water quality. But what I want to just point out is this controlled flow wetland, about 4 acres on the east side of the lake there. And this wetland basically takes water from the lake. It goes through an oxygenation system, and then water flows through the wetland, really for nutrient uptake and improvement of nutrient, removal of nutrients within the lake itself to meet some really stringent nutrient TMDL goals. And Scott, you can actually hit the next slide for me, please. The goals for total phosphorus are 0.1 milligrams per liter on a monthly average basis, and for total nitrogen, I think it's 1. And our goals for this wetland are actually 0.1 for phosphorus and 0.5 for total nitrogen. And so, what we found is the normal operating condition, the optimal operation is about 1 CFS flow through this wetland. Again, recirculating through the lake constantly, and if we can maintain that, we should be able to achieve these nutrient goals over the long term. And obviously, there's an interplay here that the city has to manage with vector control issues, obviously, and nuisance vegetation issues, but also then, of course, the water quality issues, specifically with the nutrients. So I'll just note right now, the city's actually entering an optimization phase for the wetland itself, where they're going to be analyzing its performance, because it's only been online for a few years now. So they're going to be analyzing its performance to figure out what are ways we can optimize this to really improve water quality even further. So I'll just leave it there, kind of whetting your all appetites for a few of the options we look at here in LA and Southern California for ways we can improve water quality treatment in ponds and lakes. And I'll kick it back to Scott.
Thanks, Chris. And so that's a good example of using multiple treatment trains to be able to get at the water quality issues that Chris was describing, and that was everything from ozonation, a physical type of treatment versus a natural passive type systems like the constructed wetlands. So I wanted to move now further to the east, and I was going to grab this example of Omaha, Nebraska. Now, the one thing I wanted to say that's a little bit different with this, and I know that that Matt at SD1 has similar considerations as what I'm going to talk about here, and it's a combined sewer system. And so oftentimes the driver here is not necessarily a water quality driver because it is going to the combined system, at least for smaller events. everything's going to be going to the treatment plant. The focus of this is actually more on that volume and peak flow control, which, as Bob was describing earlier, has an impact on the downstream system. The downstream system for this is actually the Missouri River, which Omaha sits on the bank of, and so they're discharging to the Missouri River, but obviously they don't want to have some of those combined sewer overflow discharges. And so the intent is to be able to provide that volumetric control. So I want to hit on a technology that's being used for a retrofit at this particular example here. And so it's in Hanscom Park, which is one of the oldest parks in Omaha, Nebraska. In fact, the north east corner up by where you see this north drainage and west drainage area come together. In this graphic, there's the Ford birthplace. And so this is a traditional park that's been around for a long time. It has this lagoon. And then the idea in this is actually a multi-benefit approach and multi-technology approach, in that the idea was to take this west drainage area that you see highlighted here in red, and then actually, which right now bypass the park completely, but to actually bring some of that flow from this west drainage area into the park, create some volume and some storage basins. So now we're creating new facilities similar to kind of what Pete was describing before in Prince George's County, but also a retrofit of what's labeled here as the lagoon, which I'm not sure why they call it a lagoon, lake, pond. You'll see it in a little bit. It's about 2.5 acres, so it's not a huge facility, but it does provide us an opportunity for further treatment. So this was the initial concept, is that we would develop some basins here. The soccer field that you see in the picture already exists, and so we're going to use this treatment train approach where we're bringing in these systems that can both have volume control but also provide water quality prior to the stormwater entering in the lagoon. So these are also what I would consider pre-treatment type of facilities before discharging to the existing lagoon. The other piece of this that we're including in this is bringing this notion of automated controls. And so I wanted to show a little bit about what that is. Pete mentioned it before with Opti. And so what we're doing is similar to what Bob was showing with that passive control. Instead of having a passive control at the end of your pond, we're actually bringing in an automated control. And so I'll show you a little bit what that looks like here. So we have, we're bringing in a forecasting system and being able to predict what storm events are going to occur, or predicted storm events based on the forecast. We're doing some web-based processing of that in the cloud. So we're taking the National Weather Service's forecast from NOAA, and we're taking it into the web dashboard, and then we're also actually doing some analysis where we've run a bunch of different scenarios for models, and then we're using that information to be able to control the actuated valve so that we're able to release the correct volume of water, essentially, to create more storage within that lagoon. So this is kind of the way that the system looks if there's wet weather. Flow comes from that western drainage area. It actually fills up these systems. And I should say that, by the way, that the cascading bioswales, they fell out of the design when we needed to do some cost savings. And so we still have this dry detention basin that's up at the upper end, and then an infiltration basin, which actually has two components, and then the lagoon is where the water goes after that. So this is what it looks like typically. Here's that lagoon or pond. You can see this is a permanent pool. It is lined with these limestone blocks. This is the way that the pond was originally. It is being fed by tap water or potable water to maintain this permanent pool in this. And so the idea of what happens with this is that we have that normal permanent pool, but when a storm is coming, we draw down that pool to a volume that's equivalent to what the anticipated volume is that would come from the storm event. We also have a little bit of freeboard on there, so we have some margin of safety, so we have some bounce that it can go up higher than that if we're inaccurate in our prediction. And so this is what it looks like when we're looking at that. So this is prior to the storm. If you can kind of look at this, you can see the edges have drawn down. We've lowered the pond water by about 30 inches to create that additional storage volume using that real-time control. And then when we have the storm event happens, it fills up. And again, we have about that 30 inches that we can work with for additional volume. And then afterwards, it draws back down to the normal permanent pool level. And we can actually time that discharge in a way that will protect the downstream combined sewer system, so that we're using the overall system modeling to determine how quickly that can draw down, or how delayed that needs to be to protect the downstream wastewater treatment plant. So this is what it looks like when it was built. This is the upper basin you see on the left picture, and then that lower infiltration basin you'll see on the right. And there's two different parts there. There's actually a kind of a dry basin and then a bioretention cell, but together they can work in combination. And then downstream of that is the lagoon itself. So with this, added a bunch of storage, reduced the volume that would be going to the combined sewer, because we can retain a fair bit of water here. Provided water quality protection, so some pre-treatment before it went to the lagoon. And we the other piece of this is what we, and I'll mention it here, the picture on the right where you see that tree that's in the left part of that right picture. There actually is a groundwater seep right there, which is partly why that basin on the upper end of the picture is a dry basin. That groundwater seep is now replacing that potable water supply, and so that slow seepage from that spring that's on that hillside is actually maintaining our permanent pool in the lagoon, rather than using potable water now. And then all of this was done with the parks service, so that we could enhance as a part of it a lot of the parks. The playground was enhanced. That soccer field I had mentioned before was also enhanced with this. So now we're going to move a little bit, quite a bit further east. We're going to go to Howard County. I'm going to hit on some more of these controls, and a lot of you are familiar with what's happening, or what has happened with Ellicott City there. But what this is really talking about is not necessarily what happened in Ellicott City, but upstream of there, some of the small, perhaps minute things that are happening. Is a retrofit of 3 private ponds, really to work on gaining that water quality credit, but really to provide not just water quality benefits, but also the flood control, which, when unfortunate location with where Ellicott City is, as many of you probably know, with 2 rivers coming together, hitting kind of the coastal plain and bedrock, and the water doesn't have a lot of places to go. But the idea is that by using these and retrofitting these dry ponds that are up above that, we can, 1, bring in water quality benefits, but 2, we can also add in some flood control benefits with these. So with this, we're using this technology called Opti, which is a company that does these real-time controls in the weather forecasting, and pulling in this 4-foot permanent pool, so that you're getting the water quality credits and benefits that are offered in Maryland. So you can see in the pre-Opti, there were about 14 impervious area credits, and then after applying Opti, there was 26 impervious acre credits. And then they also built in, like I said, that additional freeboard, so that we could add some flood control and resiliency in there. So this is just showing kind of an example of what happened there. But just to give you the highlights, wet weather flow reduction was improved by 13 times. Average retention time was increased by 4 times, and there was even a peak flow reduction by nearly 2 times. So I don't have time to necessarily go through this graphic of how it works, but we'll quickly run through in terms of it's just trying to maintain this hydrograph, for instance, where the outlet of the pond, it tries to mimic what would happen naturally, and so it's maintaining that, again, that water quality volume here at the 4 feet, and then shaves that peak off, similar to what Bob and Matt were describing earlier. All right, so with that, there was a successful retrofit of the dry ponds. They did provide the water quality credits, so the owner was happy about that. They also are meeting, those goals between the water quality and flood control goals, and then really hoping, if things like this could be done all across the drainage, it would perhaps help some of the issues that that Ellicott City is facing, although that's part of the juxtaposition of where they are in the landscape as well. All right, so the last one I wanted to hit on are various locations in Maine. And this actually, this example gets a little bit more to that last question that Randy asked of Bob and Matt in terms of what are the regulatory drivers that would make you look more towards this downstream or stream protection. And that's what is happening in this instance in Maine. And so overall, again, we're doing a retrofit of these ponds. They're calling them ponds. I'd say they're in sizes between ponds to lakes, depending on how you define those. But the overall part of this is really developing the information, like Bob was showing, that helps you inform what kind of management you would do to be able to control those downstream conditions. So I'm not going to spend much time on this, but the idea is that we're collecting this real-time data and the forecasts, and we're modeling the information to be able to understand how the system is going to respond to different events. And overall, we're trying to optimize that operation of the system, not necessarily using, for instance, a real-time control. It's still using passive controls, but to be able to change those passive controls that would better manage the downstream conditions and the in-pond conditions too. So we're trying to balance both the low and the high flow conditions. Where we're going with this is that there is a required flow that is in those downstream areas to protect the ecology. Really, there's some fish that need to have a certain amount of flow to survive there. So as Bob was describing that Q critical, I'm calling it the Q critical / ecological here, because that is the flow that is required to be maintained throughout the summer months from these discharges of these multiple basins within a watershed, or ponds within a watershed, so that the fish can still survive there. So this is really driven more from a endangered species perspective, which also I see in the Pacific Northwest a fair bit as well. So this is just showing that difference between that post-development and pre-development before, and that we need to maintain a flow around that Q critical stage, as you see in that dashed line that says Q critical. So we're bringing that, the notion is we're bringing that post-development line down to that green line there. So this is the type of outlet retrofit that's happening. Again, I mentioned this is really informational only. So they're using the information to be able to develop the criteria that they've, and those thresholds that were described previously in Kentucky, to be able to put in stop logs, for instance, in this type of spillway, and control that level, but yet maintain that discharge Q critical that they need to have in the streams. So relatively simple, solar panel to provide some power, some junction boxes, a pressure transducer upstream and downstream, and then some calculations that are used to be able to determine that both the ponding elevation and discharge and the downstream flows. And where this is going is that multiple online systems are in this watershed, and so the idea is that they're adjusting these sluice gates or these outfalls in different ways so that they can try to keep those Q criticals within the stream, but really making it a simple type of adjustment, like a not quite, well, passive, but active in that putting stop logs in those types of systems. But look at and see how they can adjust these based on the weather forecasts, and looking at the sequencing of how they might manage each pond upstream and downstream in accordance to those different conditions. So with that, we also suggested that they could move towards a more complex system if they chose to in the future. And in that, really what we're doing is trying to bring in this notion of active controls, where we are trying to get that pre-development use the active controls to be able to match that pre-development condition, which is shown kind of by this green line here, which was somewhere in between the passive control and the active control, which right now we found is each one is not quite the same as representing the pre-development conditions. So sometimes we do need that pulsing and those flows in that, above between Q critical and the higher flows, but at least trying to maintain those Q critical flows as much as we can. So that was the objective for trying to put these types of systems into this main application and manage all these systems together. Again, it was more, the technology is coming in more from an information perspective to provide that understanding of how these things operate, and then how we can adjust those systems passively to achieve those Q critical flows, which are required from a regulatory perspective. So with adding that kind of technology and that information, really able to bring in the notion of how to manage this better. So it's really kind of more of a management information systems that is going to manage this in a more simplistic way, but then also looking at opportunities where maybe bringing in an active control could perhaps be easier long term, rather than trying to just do this from a passive approach. So I hope that with all of this, we've been able to provide some simple, kind of the gamut between simple technologies to complex technologies, really to reach these multiple benefits that we're expecting from our stormwater systems now, and looking at things like using treatment trains and unit processes to be able to improve water quality and flood control, even bringing in treatment technologies that might be a part of a more active type of system, and considering things like the forecasting approach, which is more complex, but actually does often result in it can result in better results in terms of achieving your regulatory requirements in those instances. So with that, we'll open up to questions, Randy and Seth.
Yeah, thanks, Scott. There's a lot that Scott and Chris said. That was a lot. Yeah, we only have a couple minutes right now. What I did want to launch the last poll that we have. This ties in, and then while we're going through that, there's a lot of questions that have come in. I wanted to mention to folks that we're going to share these questions with all the speakers, and we'll try to get some responses from that. Send those responses out to everybody, maybe in a week or so give people some time to deal with that. And that the recording will be available as well, and the link for that will be sent out as well, and the PDFs will be available as well. So that a number of questions have come in on that. I just wanted to address that. So while I launch this, I've got a question, Randy, but do you want a question that you want to get going?
Sure. Thanks, Seth. We've through all these presentations, we've talked about this range of passive controls to really quite sophisticated active control systems based on sensors and valves and controlled releases, et cetera, et cetera. I'm curious, civil engineers tend toward favoring passive systems. There's nothing to break, there's nothing to fail. I'm wondering if we have enough of a track record yet using these more sophisticated active systems to have a feel for how reliable and fail-safe are they?
Yeah, I think that's a great question, Randy, and I think that we're getting there is the answer. And a lot of these systems, if they are powered or something like that, we often set them up so they fail safe in a mode that allows them to still function and not be required to have, for instance, a valve that's opened or something like that, or it fail safes in the open position and so forth. So oftentimes we're including these multiple margins of safety, if you will, or different operational components to make sure that we do fail safe in a way that that is like we would expect and not risk any harm to infrastructure or public health or public safety. And so I think we're building that is really where I'm going to it. And if you do consider that while it's new that we are applying a lot of this technology in a environment where we're putting it out in the open and putting it into these stormwater systems, we've used many of these technological approaches in the past in our wastewater treatment systems and so forth. And so while it seems like we're getting more toward engineered systems in our general environment, we're definitely moving that way from a technological perspective anyway. So I think that it does provide, there are some challenges in that we're still learning a bit, but I think we're starting to feel much more comfortable with this as more applications are done.
So,
Great. Thanks,
so
Scott.
I'm sorry, Randy. Yeah, so I just wanted to show you guys the poll results that that we asked basically how familiar folks were with the types of technologies presented. It looks like it's kind of a split between being relatively new and familiar, considering implementation, but very few are using this as a common practice, and very few said that it's very familiar as well. So does that, Scott and Chris, does that resonate with you? Are you surprised by these results, or is this something you would expect to see?
Chris, what are your thoughts?
Not surprised. I think cost is so prohibitive on these things. It can be. To Scott's point, we're getting better to that end, making things more cost effective. But I know here that's it's such an important aspect of doing any of this. You have the regulatory drivers kind of requiring it at some level, but then the cost, prohibitions on the other side. Not just capital cost, but obviously you talk about the life cycle cost. Putting in ozone treatment, for example. I mean, life cycle cost on that and the operations and maintenance side. So those are the big balancing acts here. So yeah, not surprised on that side of things.
So
Yeah.
there's room to grow here, it sounds like, on the technology side.
Definitely, and I think the other driver is, how stringent are those regulations? As kind of, Matt's last comment of are the drivers there to do something like this? And I would say in most instances, no. In some cases, the TMDLs that are driving some of what Chris presented, for instance, at Legacy Park, that's a big factor. Or the beach closures that are happening in Southern California because of water quality exceedances and so forth. That's a huge factor, both from an economic side of things and a regulatory TMDL perspective.
Well, that kind of ties in with the fact that you had the $6 million man there, and I appreciate that because it dates me, because I get it. So I guess it's something that dates me as well. But the point is that we can't say that or it's harder to say that we can't do things. It's more about do we want to do things? Do we have the political will to do things, right? And do we have the drivers, and so that ties with regulations, and obviously that's uneven across the country, right? Different drivers, different places, different levels of drivers as well. So, so we have, we've gone over time, but there's still 70, 75 folks or so on board here. I did want to see if there's, Rain, if you had a couple of questions just in general for everyone. I've got a bunch of questions that have come in here, so I could ask those. So maybe we can go a few minutes over.
Why don't you go ahead with a couple of...
Okay. Well, one of the questions that there's kind of a general theme which has come in, about costs. So, Pete, I don't know, Pete, I think you're still there, and if you're not, then I'm okay. There you are. Yeah. So questions about costs, with the approaches that have been discussed here. So generally, Pete, we've talked about cost savings with the community-based programs and partnerships. And Bob and Matt, you talked about a passive. This is a lower cost option, I believe, right? And then you guys, Scott and Chris, you guys presented a variety. So any thoughts about the balance between about cost effectiveness and performance overall? Any thoughts? And Pete, I'll start with you since we're going from that same order.
Yeah, no, I think there is. It's always going to be the balancing act, right? Is looking at your total program, the amount of dollars you have to invest holistically, taking into a fact that you've got to maintain these things long term, and the more complex or the more non-passive the devices are, the more potential maintenance challenges you have, right? So that the more you have to put crews in the field. So our job is always finding that right balance between the value that the jurisdictions want to get out of it politically through the community, and then also the technical benefits of it, and using passive where it makes sense, but using, like a couple of the examples I showed, where you really have a water quantity issue, using something like the Opti solution makes sense because it makes sense to spend the dollars because you don't have the land mass to deal with the problem, right?
So technology is not always more expensive. It just depends the type of technology, it sounds like, right? And the opportunity presented.
Yeah, you have to take into account kind of the opportunity costs, right? That if you don't have the land space to generate the capacity you need, then technology is really the only way to go.
Yeah. Any thoughts on that, Bob and Matt? I know you guys have probably thought about how ubiquitous can you implement high cost technologies versus low cost technologies. I'm guessing when you're looking about a regional plan, is that correct?
Yeah, I know one of the factors that we look at is how much more benefit can we get if we go into the active system? Is there something that active system can provide as a protection downstream? I don't know, for example, a CSO volume reduction in conjunction with everything else that it's going to do that we can't get with the passive system. That's something that may entice us to go with a more active control.
Right.
I do want to follow up real quick on that regulatory question. One of the ways that the work that we're doing has been utilized by Division of Water up here is that one of our watersheds was slated for a TMDL for bacteria, and we were able to actually get them to reconsider that and give us an alternative to the TMDL approach by implementing one of the watershed-based plans that is steeped in the Q critical concept. So they are recognizing that it does provide opportunities in the regulatory side of things too.
Yeah, and just to add on to that really quickly, the passive stuff that we talked about is basically on the order of $10,000. You know, so if and it really comes down to, like everyone said, you know, what are the stakeholder needs, what are the drivers, and also the risks, right? So if you want to retrofit a detention basin where the spillway is in terrible shape and it flows onto a road, and you know the dam is like 20 feet tall, of course, you know, you want to take risk very seriously. If you're retrofitting a smaller pond with a smaller spillway, and you know, then a passive system might be, you know, pretty easy to do. So anyway, it all kind of comes down to that. We've used both for different settings.
Yeah, excellent. Thank you, Scott and Chris. Any thoughts on because you guys showed a whole range of different costs and options for different types of technologies.
Yeah, I would just second what Bob just said. You know, a lot of it is a risk-based approach to understand, you know, the costs and benefits, and looking at those full life cycle costs is critical for that. You know, you're not just looking at just the construction costs, but you're looking at, you know, the full O&M for the lifespan or even longer, so that you're including those replacement costs like Pete had mentioned earlier. So all of that's a critical piece of it. So, you know, having a framework that you can make those decisions on a case-by-case basis is what's needed.
Yeah, Chris, any thoughts?
I was just going to reiterate that, going to what Pete said. I mean, we've seen it here, unfortunately, in Southern California, where there's so much pressure to get something in the ground, and so people aren't looking at whole life cycle costs and putting in projects, and a few years down the road, they're degraded and just not functioning as they're intended because they've neglected the whole O&M side, and they don't have the funding or the people, the staff to maintain these things. So just an encouragement to really look at those costs when you're analyzing these things. It's so critical.
Yep. So we've talked about a lot of different approaches and technologies. Do you think we've covered 5% of the available technologies out there, or 90%? Just to give some context for the audience to know, like, is this just scratching the surface, or does this cover a lot of what's used out there? And I guess I'll ask. I'll go backwards this time. I'll ask Scott and Chris first on this.
Well, Chris, I'll let you go first. You mentioned the first number.
Oh, I mean, I think we're scratching the surface. Somebody can disagree with me, but in terms of both, I mean, I think obviously we need to be innovators and think more creatively, you know, and hopefully things continue to progress and getting more creative in ways we can improve, in this case, ponds and their effectiveness. But yeah, I think we tried to look at and cover kind of some general subject areas, but then within those, I mean, the options seem to be pretty endless as far as technology that can be applied. I mean, you can go down some pretty go down some holes pretty deeply about different technology and from vendors and things that are provided to do the things that we're talking about doing here. So that's kind of my take on it and seeing that done. I mean, one thing I didn't even mention, for example, not getting a little bit away from technology, depending on how we define that, but one of the things we look at here is actually adding things like dry wells to ponds or even offline from ponds to increase infiltration. So then we're increasing water supply, which Scott mentioned, especially in LA, is such an important aspect, a vital aspect to what we're looking at. So, there are things like that I know we didn't even touch on. So that's kind of my quick 2 cents on that. Somebody disagree with me?
I would say that, yeah, I mean, I think we've hit a lot of things. If we just include those as broad groups, as Chris said, like, treatment trains, for instance, whatever widget you're talking about in that treatment train, whether it's active or passive, I think, that's it. I think looking for other opportunities, the parks, both Pete and I hit on being able to retrofit parks and find more space. And I think, Matt, maybe even you talked about one of those too. Those are the kinds of things that we have as tools in our toolbox. And I'm sure there are things that, we haven't hit on, but certainly I think we've hit on a lot of what's being done out there, again, from simple to complex.
Okay. Matt and Bob, you guys feel like, is there a bigger world than what we're seeing there? Or do we feel like we've covered most of the categories of pond technologies?
From my perspective, especially when we looked at it from the optimization side of things, I think we got a lot of encouraging results. I think we're just scratching the surface on what we can do to get the most out of these ponds. I mean, we're starting simple and we can go to complex. So, as we learn more about the systems that are receiving water, how they respond to the interventions that we're doing, we can adjust accordingly. That's kind of like the key to adaptive management.
Yeah, that's a good point. Bob, any thought on that?
Yeah, and like Pete was saying, it comes down to stakeholders and the setting and, the neighbors and what they want. And then, like, if you're in Minnesota with Randy, phosphorus is a big driver. So, how do we optimize there? Some of the ponds, we make them stream wetland complexes. Like, they don't even look like a pond anymore, right? So it just, infinite possibilities. I just echo what the others say. Okay,
and Pete, any last word on this?
No, I just think it's encouraging that everybody's looking at it kind of holistically at this point, right? Instead of one project at a time. And I think it's really important to look at the scenario rather than trying to force technology in when it's not necessarily needed. You know what I mean? So let the landscape dictate what you use.
So it looks like technologies allow us to be to tailor things as we need to, and we've got more options. You just see more and more technologies that are devolving, and I guess I'm thinking this in the context of ASCE's releasing a report card in 2021. It's going to include stormwater for the first time, which is great, and ASCE should be commended for that, and NMSA has been behind that, and WEF and others as well. But one of the categories is innovation, and so it makes me think I feel like there's a lot of innovation, more going on in this space than I think folks think. So this is one aspect of that to talk about. So we do have to wrap up. We're over time, but I think we got a lot of people who stayed on. I appreciate everyone, all the speakers preparing, wearing collared shirts for the first time, and who knows how long. Maybe I'm projecting on that one. We do have another event coming up. It's either going to be October 21st or 22nd, same time. I don't have the link yet, but we'll send information out. Everyone will get again, PDFs, assuming that's okay with all the speakers. I guess it's a loaded question right now, but we'll send PDFs out to folks and on what we've seen so far. And Randy, any closing remarks?
Just wanted to thank Pete, Matt, Bob, Scott, and Chris. Also, your work on this, Seth, as well. It was another good webinar, and your assistance is greatly appreciated.
All right. Thanks, everybody. Thanks for joining us. Thanks for all the speakers, and we will be talking soon with everybody. See ya.